Okay, let's unpack this. Imagine a construction system, right? One that claims it can fundamentally change, well, pretty much everything: the speed, the strength, even the whole life cycle of a building.
Hmm.
That's the promise we're deep diving into today. We're focusing on this one specific modular architecture system, and it's built around four big claims: strong, lightweight, sustainable, and certified.
Exactly. And our sources here, they're quite technical. We're looking at the documentation, the structural specs, and also, really importantly, the global business side of things for MHS building systems.
Right.
Because, it's one thing to invent something cool, but engineering the scalability,
Yeah.
that's a whole different ballgame.
Yeah, it really is the challenge, isn't it? I mean, traditional construction, it's slow, it generates a lot of waste, and it's so dependent on specialized labor that's, hard to find sometimes.
Right.
So our mission today is basically to cut through all this data, all these specs, and figure out what makes this aluminum-based system genuinely unique. Is it just the sheer strength they talk about, or the business model for rolling it out globally? We need to figure out if this is like the real future or just another niche idea.
And what's interesting is how the core engineering seems to directly feed into the sustainability part and the business goals. They're aiming for simpler logistics using standardized panels and frames.
Uh-huh.
That should make global fabrication and shipping easier, which, let's face it, is often a massive bottleneck for modular building.
Okay, so let's start right at the foundation, the engineering. What's the material science here? What's the core concept behind MHS that they think can really change the game for modular construction?
Well, it all kicks off with the material they chose. 100% recyclable aluminum extrusions.
Aluminum.
Yeah, and that choice seems really deliberate. It tackles weight, obviously, but also end-of-life waste right from the start. Aluminum means zero waste modularity in theory, and it holds its value really well, high salvage value. Unlike steel or wood framing, which often just ends up in landfill, this stuff is naturally corrosion-resistant and totally reusable.
Okay, sustainability sounds good. But historically, you think structure, you think steel, you think concrete. Brute force, right? Aluminum's light, sure, but we need serious strength.
Yeah.
That's where these claims, and especially the certified part, really have to hold up. Let's dig into the main structural component, the MHS 170 series, their primary structural frame.
Right, and these aren't just like standard aluminum beams you'd pick up anywhere.
Yeah.
The 170 series profiles are pretty beefy, 6.69 inches by 6.69 inches.
Okay.
They're tested to ASTM B221, which is, a necessary standard for aluminum alloys, but that's just table stakes, really. The number that really jumps out, the kind of key insight here, is the sheer strength. Engineer-verified sheer strength.
Let's put that in context for everyone listening. Sheer strength. That's the force needed to basically break a connection, right? Make the structure fail at that point. What's the number they've verified?
Get this. They claim over 25,000 pounds of sheer strength per connection.
Whoa.
Yeah.
Okay.
To really appreciate that, think about a standard wood frame connection, maybe a few hundred pounds, if that. Even the heavy-duty steel connections need serious welding or big bolts to get into the tens of thousands.
Right.
This system apparently hits 25,000 plus pounds with just a mechanical clamping system, rapid assembly. So you pair that crazy strength with the fact that it's lightweight aluminum, resists corrosion, you get a frame that's super durable and supposedly very fast to put together.
Wow.